back. So I think this is going to be the third video on the subject N Queen, and I think in the previous first and second video we discussed about uh, we tried to understand the problem first, and then we tried to look at the solution. Okay, so till now we were here, and as I mentioned you, we are at the somewhat the third level out of five to get the maximum out of this question. Okay, so this question in itself is not a question itself, but it's a series of things which makes this question very interesting. Okay, and now let's try to uh, extract those patterns out of it. Okay, so the objective of this video would be to understand the patterns behind uh, these kind of questions. Okay, and I feel like this is the most important pattern. Okay, so let's try. Okay, so first let's try to do a small rewriting of the question. Okay, rewriting means we will just try to write the variables name slightly correctly, or that makes more intuitive whenever you will revisit it. But and also if you can make some here and there some variable changes, that can make it more understandable. So okay, so that's what we will try to do first. Okay, and then in the second run, by the end of this video, probably you will have some level of understanding of the patterns which are there in the this question. Okay, so okay, so n is equal to 8. If you remember, it is a given thing, and then we created an empty list, and our intention was that during our entire program cycle, means we will do something so that we can fill this solution. Okay, now let's try to go ahead, and let me make a new board because I think a new is required. N Queen pattern. Okay, so now what I will try to do, I will try to walk you through how we are translating the question, like the step-by-step procedure by which we are able to though we can understand the code, but that's not the I feel like this step is everyone can do, and the readability is there, but if you will come back to this question later on in the future, you will not be able to do it again, and that can be fulfilled by this step which we are going to talk about here. Okay, and the primarily we are trying to find out the every small steps that we are trying to do in our code, translate it to real life. Okay, so how we are approaching it, because in theory you know how you are doing it, but you still will not remember all of these steps if you have just seen in the code. Okay, let's start. Here, let me place a queen. Okay, here we have a queen. Okay, 1 2 3 4 5 6 7 8. And okay, let's start doing this. Okay, so this is the question I'm given with. What I'm given with? I'm given with a number which is 8. I'm given with a number which is this. Okay, this is what I'm given with. Okay, and this translates to this. Okay, a board which is like in theory looks like this, like in real life scenario it looks like this, and we want to place the equal number of queen. Let me do one thing which will make it slightly more good. This should be fine. So we were given with this and we translate it to this. Okay, now let's represent this this configuration into writing. Okay, because that's the most important part, how simply we can represent our problem into. So none, 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 none. Okay, let's do one thing to be very specific. Let's have a small list. Okay, and let's make it of the color. Okay, and okay, and let's make it as white or black, let's say, and let's mark it as none here, and let's color it down. None, 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 3, 4th, 6th, 7th. Okay, so this is the board configuration. This is how we are representing. Okay, maybe I will retake this part, but because it took slightly some amount of time. But again, this is what we were given with, which in practicality translates to this, that you have some number of queens, which translates to the number of the same number of rows and column, which makes it a chess. And the and in theory we are representing it as a list. Okay, the list of some elements where none represent the queen is not here in this part. Let me try to represent otherwise. Let's say if I put the queen here. Okay, so in theory it will mean queen it at the C position. If I keep the queen, let's say here, it means the queen is at the D position. Let's say if I keep the queen here, it means the queen is at E position. if I keep the queen here, it means the queen is at A position. And similarly, let's say if I keep the queen here, G position, let's keep it here. B position, let's keep here, translates to C, translates to H. Okay, so in theory, this is what how a board is board on which queens are placed is represented. Okay, and this is the column in which things are there. Okay, I could do the same thing with numbers as well. Means like, of course, in if this is a list, you know, like the very first index will start from 0, and this will start from then 1, then 2, then 3, then 4. And but in reality we call it like something like this, so I'm not keep changing it. I hope this much level of like some level of understanding you might have. Okay, now let me take you back to the mother nature, and let's take it up and let's take it here. Okay, and let me extend out the question, and again let me put the safety because I don't want you to be overwhelmed with the question what is written. Okay, yeah, so this is the question again. The n queen puzzle is the problem of placing n queens on n by n chess. Given an integer, return all the distinct solution to the n queen puzzle. You may return the answer in any order. Okay, so this number 8 is this number 8, and we want to return some number of we want to return the all the potential solution. Okay, so till now what we did, again we visualize the what we wanted to, then we translated it into something which can be like which is a sort of a data structure for remembering the values of a chess configuration. Okay, so this is what we did so far. Now there is an example how it looks of the different board configuration. Are these correct? No, these are not correct, so don't think that. Okay, okay, now we have a chess board of n cross n configuration, and from here on now we will start with the objective of this particular video. Now how we are solving this problem in theory, what we are doing. Okay, to any question what we are giving is let's just start with this, because this is something we will start with. This is the board. Okay, we give the number of okay, so first we will give them, let me give I think I don't have the object, but what do we give? So we have a function, let's take it let's say a function. Okay, this function this function what it takes. Okay, so definitely it takes a board. Okay, board in this case is this, let's say it takes a board, it takes a board as an input, and then it also takes in which column you want to uh, like you want to add the queen. Okay, in which column you want to add the queen. Let's say for purpose of this, let me okay, let's say this is the column in which I want to add the queen. Okay, and so I will give this also as an input. This column. Now if these two things are given, what else I need to give? This is somewhat a constant thing, and like these two things are static, like are going to remain static. So we will rewrite it, but let's wait for a few seconds before we will do. Okay, so this is the crux of the problem, like how we are solving it. Okay, so let's say I could have let's say B here, this is the one, and this is the one. Okay, so B, D, and F. Okay, and now I want to place my column here. This is the question. Next question, what would be the next part? Now this will produce a board configuration. Again it will give me an okay, let me do here. Okay, this will output me a board configuration. Keeping the queen at certain level, let's say H. It will keep the queen at H position. Okay, which will make the board look like okay, which will make the board look like this, and this will be kept here. Okay, now let's keep it here. Now again same thing will happen, and this time of course the board will go, and of course now this time the column to fill is this one. Okay, and now instead of this, the column will go here. Okay, so now we see I given this problem statement a board with some configuration. In return, this function gave me, let's make it like this, let's make the color also different. Okay, in return this function give me another board with the value placed, and then this function itself then is going to call uh, itself with the call to fill the next column. Okay, I hope till here it is clear. So first configuration was this, and the second configuration is this. Okay, notice the fourth column previously was filled and now the fifth. Okay, and the same thing will repeat itself. Okay, so let's copy this part. Okay, and let me paste it here again. So this give me result, and then where I can place what happened 1 2 3 4. Oh wait a second. Okay, and this time now this queen can be placed here probably. Okay, so this is giving me this answer. Let's don't assume, let's say gh and it goes to e, and now the next time the function would be called would be for sixth column. Same thing repeats, copy, paste, next part, and now next column will be called up later on, and then in this way can I fill here? No. Here? No. Here? No. 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 Here? Yes. Okay, so here I was able to fill. Oh no, sorry, I cannot fill here, no, because here I can just select this here I can fill. Okay, now let's move to the this position is A. Same thing will happen again, and I will go to the next time, and what will happen now again. So next time it will go here, but I am trying to fill this column. Now where I can go? Can I, let's remove this. Can I go here? No. Can I keep my queen here? No. Can I keep my queen here? No. 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 Okay, so all in all I was not able to place my queen here. Okay, so if I'm not able to place my queen here, what will happen now? Try to think now, what should I do? In theory, what should I do? Like, should I, because the previous pattern was like I will find the solution, like where to keep, where to place, and then I will call the function. Now since I'm not even able to find the solution, so what should I give? Of course I will not call anything further, that's clear, but what to do with the board with which we are given with, what to do now? So now what if let's try to see this particular location in the code. Okay, so this function will execute. Okay, and if it comes to within this function, okay, what it will do, like it will continue, and but if it arrives at here, it will not go anything beyond it. That's clear. Line number 20 it will return. Now in the line, okay, so suppose this was not passed, this condition. If I come here, and now this particular code will like run for a certain number of times, and if this condition is not met, what will happen? And this is what exactly has happened now. So like uh, I was not able to place my queen anywhere. I was not able to queen anywhere. So in theory it will return false. Return false means function was given this, function was not able to output anything, means like it did not outputted anything, and this is the behind the scene. But now let's take up the arrow. Okay, it returned nothing. Let's take it here. I make an arrow there. It returned anything, but where it went to the previous board configuration. The previous board configuration input was this, and once it finds queen to place position, it calls a function, but that function call is this time is not giving anything. Okay, if it is not giving, so suppose now you are at this location. Okay, previously this used to go deep and deep and deep and deep and deep. Okay, if you see, but now this time it returned false here. Returns false means like this uh, part did not went further in, but it's just says like now just do one thing, make the uh, mark this column as none. Now, are you getting? No. So what does it mean? It says don't go any further. Okay, mark let's take this one, copy, and return. It says previously what you assume that you can keep your a here. Okay, now marked it as none. Okay, now if this is marked as none, what will happen now? The next loop will run. Try to think. I know it's complicated, but now this is also marked like, so in the previous step, like we marked it as none here. Now what will happen next? Just think in that direction for row and ranges. So like if you remember, this thing was this. Okay, and this column equal to row means I am going to place my queen here. Okay, so let's assume if this queen was here previously, by which we were going ahead, this was marked to something, but now instead of this we say no, this is not going to be placed, and we mark it as none. Now what will happen? So there are two scenarios. One scenario is like in which, let's say the position was something like this, means like we were proceeding after this point, but now that is comes out to be none. So what will happen? It will go to the next loop, next row, and do the same, try to do the same thing. Okay, but in worst case, if by the end of it we are still not able to place our queen as none and all iteration has passed and this is coming out to be none, for in this scenario that is the condition. Now what will happen? It will say false. It will say false means now the same cascading effect will go, which means like this function is not giving me anything, it is saying go back. Okay, so go back it is saying, so I will go again back, and now this will be here, and it will say no, I cannot keep anything in the none position. But this is the first time, like first loop, like of course the sum loop. Now I will go ahead and try to do the next time with the try to keep this into this position. Can I keep? No. Can I keep it here? Yeah, I can keep it here. And then I will go for C, and let me do this in the below. Okay, now same thing happen, C will be applied and the same function will then be called again, and let me make it okay, and the same function will be applied. Let me take it, so this will be taken, and again the next one will be taken, which only difference is like previously we thought like E is the solution, now we will do with the C, and now the C will continue. So C will call, I mean like if the C position is here, C will be called, and ultimately, so if you see by the end, okay, there would be, okay, let me do one thing, let me run it for one time so that I know one solution. 047526130, 047526130, 0, okay, let me place a position here anywhere, 047526130. Okay, ultimately, so there would be a dot dot here somewhere, but let me 0 4 7 5 2 6 3, what was the number, 047526130, 6 1 and 3, 0 1 2. Okay, so this is the solution, which means like it is placed in H, it is placed in D, it is placed in A, this is placed in C, this is placed in F, this is placed in B, this is placed in G, this is placed in E. Okay, is this threatening any other? No, 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 no. Okay, so this is a potential solution. Once it get to this solution, okay, so I did something, I did a lot of runs here and there, here and there, here and there, and at whichever level I am, okay, so the next question will become, I want to place my queen here at this position now. Okay, so the column will go this one, that I want to place my queen to the 10th, and this is when this condition will say now your column value is greater than the number of queens you wanted to place. So do one thing, take this combination, take this board as a solution and add it to your list of solution. Okay, let me close it up. Okay, so this is a valid solution. And suppose this has happened in the very late era, Now what will happen if this was the correct solution? I need to go back to a feasible, let's say, where I will go, like I need to go back um, so understand this previous problem is now solved. Okay, what I mean is I will go back one level, okay, with the saying let's mark this position as none again. Okay, place the queen and then remove the queen from there. Okay, so I place the queen, now I'm removing the queen from there. Okay, now in the next solution what I will do, I'm going to go ahead this and check if the same thing applies or not. Can I keep? No. Can I keep? No. Can I keep? No. Can I keep? No. So this is this this time, like I was not able to place the queen here. So what will happen? I will say I was not able to return anything. So don't keep. I was not able to like place my queen there. Okay. And now instead of this iteration, now I need to go to the next iteration, and then this will again call up this one, this pattern. Can I place it here? Here? No. Here? No. Here? No. 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 Again no. Again I need to remove the queen from there. Okay, so this, when I'm like this is like ending this what we say, this loop is getting terminated. This is not making it as none, but this is a loop is getting generated, which means it is returning false. Anytime I reach here it means false. Okay, if it is false, now I need to remove the queen from here, which is remove it and then move to the next cell and then keep it again, and this pattern will continue. Okay, now I need to keep here. Can I keep? No. Can I keep? No. 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 Okay, so something like this will happen. So in theory you are able to see, like not in theory but just basically you are able to see some sort of pattern. Okay, now what is that pattern? That pattern is let me take an empty board. Let's take it. And that pattern is you start with 1, okay, and then you immediately, if it is good, you go to the next column, try to place the queen anywhere. If you are able to place it, place, and then you again immediately move to the next column trying to place it. Whenever you are able to place it, you place it and you move ahead to the next one. If you are able to place it. Now this time let's say yeah, I'm able to place it. Okay, let's say if I reach here it means false. Okay, if I am able to place it, yeah, place it. Okay, let's say yes. And now let's say if we look at this, can I place it here? No. 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 Okay, so if I reach this position, it means I was not able to place it anywhere. Okay, and now this position needs, okay, this is like uh, end of the row loop, end of this row loop, returning false, which means now the previous run, like which was here, I was trying to do this part here. Now I will say don't no, like the chessboard for this position is marked as none. It's like I am not able to place anything here. Let's try the next solution. Can I place my queen here? No, no, no. So this is also marked as false. This is also false. I will try to go here. No, 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 false. Here, can I place? Can I place it here? No. Yes. Okay. So let's start from again from here. Can I keep my queen here? Here? No. Here? No. Here? No. 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 Again false. It means this will get the pattern. Okay. So when I'm saying things are false, it means you're returning back to the previous loop approach. Okay, so this is the pattern. Okay, okay, so we I'm throwing at you the most complicated term, this at you from within the last minute, but how you do in the real life, let me show. You do the same thing. Okay, and it will feel like the brute force to you. Okay, you keep your queen here, and then you check if something I can place, yeah, and then something I can place, yeah, something I can place, yeah, something I can place, let's say, yeah, something I can place, let's say, yeah, and then later on you, okay, let's place it here, no, somewhere, where I can place this one. So this is gone, this is gone, this is gone. Okay, I don't think I can place it anywhere. Okay, so anytime I hit something which where I cannot place, I delete it, I increment this. If I'm able to place it, again I take the next one, I go here. If I'm not able to place it, I move it, I try again, and if I'm not able to place it, I delete it, I move it again, and then I check for this entire. If I'm able to place it, I go in more depth, I go in more depth. If I'm able to place it, let's say I go in more depth. If I'm not able to place it, I go back to the previous and run it. So this is the pattern behind this question. Okay, so I will not I would okay, so this is especially a very complicated loop for the brain, so I would like to rest here for today, but let's carry on this discussion, what can be further taken out from this. But yeah, this is not the end, so we are on the topic of the pattern recognition. Okay, so what's the pattern is and how we are able to translate it to the code again itself is very small, but the level of depth which is there in this question is very hard to comprehend. So it's a very intelligent way to write a for loop. If you see here, anytime you run out of option, you say false. Okay, and if something is returned at false, then your previous iteration will run. Okay, if something is returned as false, your previous iteration will run, like will try to continue. So what we do, you place your queen first at a position and then run through all the combination. If no combination was found, you move ahead. Okay. Okay, so this is something what is the crux of the question is. Okay, so the pattern part is almost done. We will try to further discuss on it, but like in the upcoming session we will talk about uh, what coding pattern is there. So till now we discussed about the human pattern which if we can find it out, we were able to. Now we will discuss from the coding pattern. I will, and most probably I will show you the entire recursion stack for this problem statement, and I think we will be able to get more out of this question. Okay, thank you so much.